So this is not the last rule for derivatives, period, but it is the last rule we're going to be learning in this class. On one side of your formula chart that you just got, it says derivatives formula chart. Those are all of the ones we've learned, minus the one that says higher order and the chain rule. Chain rule is today, higher order is next time. But if you look on the back where it says derivatives and integrals, those are all of the derivative rules and all of the antiderivative rules that you will learn in calculus. Obviously, I have not taught you most of the things on this page, but I wanted you to have a nice resource for when you ever take calculus. So you have here a formula chart of all derivatives and integrals, which are antiderivatives. But on the front side of it, where it just says derivatives formula chart, those are the ones we've done in class or will do in the next couple classes. So you can bring your formula chart to class. You can, not on the next quiz, but on our final, if you're taking the final, you will be able to use your pre-cal formula chart and then this derivatives formula chart. Just putting that out there. Okay. The chain rule is kind of a blanket rule that goes to any other rule we've learned. The chain rule can be tucked into a quotient rule. The chain rule can be tucked into a sum and difference rule. It can be in all of the other rules, so it's one to really kind of understand. It allows us to take the derivative of a composite function, meaning there's a function inside another function. Do you see how g of x is inside of f of x? I just did my color scheme backwards. G of x is inside of f of x. Yeah. We are going to run into equations where we need to take the derivative of something that has a function tucked inside of it, which has a different rule. The rule is that you take the derivative of the outside function with the old inside function still plugged in, not the derivative, just the regular function. And you multiply that by the derivative of the inside function, which is a lot of letters. We do not use U's and V's in this situation. You may have a professor that does use a U in this U substitution moment. I am not going to for reasons you might notice later. What we are going to do to find the derivative when we notice we need the chain rule is, one, we're going to figure out what the inside function is. Do y'all see how 3x minus 7 is tucked inside x to the 5th power? I don't want to sit here and multiply 3x minus 7 5 times because that would be really large. So instead, I'm going to use the chain rule so that I can just do it without having to expand this polynomial first. So what I do, let me finish highlighting here, is I'm going to write the following, bless you. We're going to write f of g. There's not x, which means I'm going to be substituting in some value for g. F of g is just going to be g to the 5th because we'll let g be 3x minus 7. This is essentially the u substitution we've done before. We're just not going to use the letter u for reasons you might notice if you try to say it out loud. So when we do this, we're taking the derivative of both f with respect to g instead of x, and then of g with respect to x, meaning if I do f prime of g, not x, all I have to do is pretend like my variable is g, like an x, and this would be 5g to the 4th power. Power rule, right? We follow? Yes. Great. Then I take the derivative of g, which is just 3. So to do f prime of x, I have to substitute everything back in, which means I will be doing the f prime part, but inside of that is no longer the letter g, it's going to be the entire function g that has an x in it. But the derivative for this chain rule also tells me that I have to multiply all of this by g's derivative. So it's the derivative of the outside function with the old inside still tucked in, multiplied by the derivative of the inside function. So the simplification, I'm not going to make you multiply out something that's to the 4th power. Really, honestly, to the 2nd power is the only thing I'm going to want you to multiply out. So here we would just multiply the coefficients of 5 and 3. This would be 15 times 3x minus 7 to the 4th power. That is the derivative. We couldn't just do it without this power. Before today, you would have had to multiply 3x minus 7 to the 5th out then take the power rule. And that's super annoying. So instead, we have the chain rule we can do to make it much faster. So basically, you're putting a placeholder function, g, into f to take its derivative, and then putting it all back together at the end. Does that make sense? No time like the present to try it for ourselves. Part B is yours. You got it. If it's helpful, I will go ahead and highlight inside and outside. So maybe that's a place for you to start.
So g is always the inside, right?
Correct. Yes, we're going to let g be the inside function. I just picked the letter G because of the way it works with the formula, but it could be any letter. So I feel like at this point, we're either getting close to an answer we think might be right, or we're stuck. So I'm going to start writing it up on the board. Don't look till you're ready. Okay, how many of us got at least this far? Yeah. Woo, that's the chain rule. That's the calculus moment. It's just the algebra after this that's going to change it up. For this homework, I know I just said that I would love squareds to be multiplied out, but that's when they're cute binomials. A trinomial squared, we're not going to worry about it. But what we are going to worry about is coefficients and non-squared terms. Meaning, I would like for this to be simplified to 72x squared minus 36x multiplied by 4x cubed minus 2x squared minus 1 squared. And that's fine for me. Yes. Oh dear, what did I do? Where?
At the 2x squared.
At the right side at the bottom.
At the right side at the bottom.
4x cubed minus 3x squared.
That is so embarrassing. I just straight up wrote that down wrong. Yeah, I can't even use my Monday excuse.
We've been testing all.
Yeah, blame the testing.
We're just a little scrambled. It's almost Friday. It's the end of the year. It's almost Friday.
Yeah, I don't know.
You're
Where did I?
ready to pull me out too, right?
Where?
I would have purple should put equal 1.
Oh my goodness. This is so embarrassing. What it should be, is it minus or plus? It should be plus.
You know what's funny? She also put minus 1 at the bottom.
Right. Okay, let's see another example here.
I think we should just like stop doing this.
Nah. Okay, this is another chain rule. Doesn't look like it because it doesn't look all that complicated. However, do you see that there is a 5x plus 1 tucked into a square root? That makes it a composite function, which means we need to chain rule to be able to take its derivative.
Yes, the g of x is square root.
Okay, so the f of g, is that what you're talking about?
Yeah.
It would be square root of x. Now, we can write it like, it's not square root of x, square root of g. We could write it like this, but that's not really helpful for taking the derivative. So instead, how should I write it? To the power of 1/2. Because that's going to be helpful for us to take the derivative. And then we say, okay, but hold on, g is going to be 5x plus 1. We're just substituting this for a second. Okay. When we do f prime of g, this is 1/2 times g to the negative 1/2, right? Multiply by the power, subtract 1. G prime is going to be what? 5. Okay, great. So we put it back together. Again, kind of with the way I've been doing this, I'm not going to clean it up and get rid of my exponents being fractions or negative to the very end. This is f prime of x, which means I put everything back together. 1/2, open parentheses for g, negative 1/2 power, and g is 5x plus 1. But all of that's going to have to be multiplied by 5.
Wait, so you don't put it back in the square root function? You just
I will.
So 2.5, right?
I will. So it is 2.5, but I like fractions. Y'all know me. So this is going to be 5 over 2. And then I have a negative power, which means what? Okay, so I'm going to make my denominator bigger. Okay. And when it's in the denominator, it's still to the power of 1/2, which means what? Which means it's a square root. And I'm going to move this 5 because it just looks weird when it's in the front like that. It's not wrong, just I don't love it. Voila. There's your derivative. How do we know to put what where?
The fraction.
The 5 over 2?
Yeah.
It is just the fraction 5 over 2. I just like my numerator to be centered. That's just
No, like
formatting.
The square root part. Like,
How do we know to put that in the bottom?
oh, because of the negative half?
Correct. Yes.
Cool. And if it was positive half?
You would have left it in the top and just made it a half or the square root.
What do you mean?
Like if, okay, so he's asking what if it looked like this? Right? That's what you're asking?
Yeah.
So then I would still have 5 over 2, but the square root would stay in the numerator, which means you can either write it in the numerator next to 5 or just next to the fraction 5 over 2. You wouldn't have to put it in the denominator if it's not negative.
Okay.
Bless you.
Thank you.
You're welcome. Okay, when we come back from lunch, because I'm assuming we're going to get there, we'll go over part D, which means in this next 1 minute we have before we go to lunch, y'all go ahead and try to start working on D. And yes, I gave you the hard ones. Because you can handle it.
No.
Yes, you can. After we've gotten this far, right, we have our inside function or outside function, guys, which means g is x squared plus 4. So if we take the derivatives of both, f prime of g is negative 1/2 g to what power? Negative 3 over 2. And then g prime is just 2x. Great. Let's put it together. So if we actually wanted to do f prime of x, we would have to keep the f prime of g, but instead of g, like the letter g, we write g the expression, x squared plus 4, and multiply that by 2x. Then we get to the cleanup step. These two values here, negative 1/2 and 2x, are just kind of like coefficients. So we're going to put them together where it would be negative 2x over 2 times x squared plus 4 to the negative 3 over 2. I'm doing this on purpose. Some of you probably simplified differently, and that's fine. I'm doing it like this because I realize, oh, look, a 2 on top and 2 on bottom. That's going to cancel, which means I would have only a negative x on top. And in the denominator, I would have the square root of x squared plus 4 raised to the 3rd power. Now, a couple things to talk about here. Why did I need to put the parentheses around this term right here?
because
You're not
you're cubing all.
I'm still cubing all of it. Why did we not need that in this problem? I didn't put parentheses.
There's no power to it.
It's a power of...
The numerator is just 1.
Numerator's just 1. It's power 1, so we don't need parentheses. Everything is power 1. But if it's higher than power 1, you will need to put that stuff in parentheses to give it the power to everything. Questions, comments, concerns? The chain rule also allows the derivatives of trig functions to be far more interesting.
I still think a U would be better.
You can do it if you would like, but I will be using g's. If we're doing this one, it's very obvious what the inside function is, because it's truly tucked inside of a trig function. So we have our inside function, we have our outside function, so we can rewrite it. This is kind of fun, specifically this problem when we're substituting in a g, because guess what? It's the sign of g. It looks like sing. And I don't like the way that looks. So I'm going to put it in parentheses because otherwise I just see the word sing. So I'm personally going to put it in parentheses. You do not have to. I just think it's better that way. Otherwise, I just get distracted by the fact that it looks like a word sing.
We're starting with prime again.
Oh, nope. Thank you. That should just be f of g. Now when we do f prime of g, what's the derivative of sine? Cosine. Again, I'm going to put the g because it just looks weird to me because it looks like it's trying to be a word. And it is not. G prime is 3x squared minus 2. And so if we put it together using the chain rule, f prime of x would be equal to the cosine of g, which is x cubed minus 2x, multiplied by 3x squared minus 2. Now there's not really any cleaning up for this one besides reordering. We typically in mathematics put trig functions at the end of terms. So what I mean by that is we should really write 3x squared minus 2 multiplied by cosine of x cubed minus 2x. I know those are 1000% the same thing, but this is a more appropriate way to write it with the trig function going second. And yeah, you could distribute the cosine to both of those terms, but you don't have to. Feeling pretty good? Maybe. Let's make sure it's right. F is for you. And that's why we don't use U as a letter in the chain rule. Precisely that reason. Moving on. All right. Okay, so I guess I did this one without really saying anything, but y'all look up at the board and see how we did. So you may not have really realized that we had been avoiding doing problems of composite functions until today. We've just been politely avoiding finding the derivative of those. But now you basically can take the derivative of almost any polynomial, any trig function, and any rational function or square root function, because now we know what to do when the stuff inside those functions is more than just a single number or a single letter.
I have a question.
Yes.
Do you, in like these types of equations, do you never use f of g in the equation?
What do you mean?
Like, for this one,
Mm-hmm.
how it says cosine of g, you never use that in like the final equation with plugging in everything in?
Correct, because we want to find the derivative of f of x. G is just a placeholder. Before today, we always used the letter u as a placeholder. Like when we did our trig solving, we did the u substitution so we could factor. And that's just because mathematicians don't really use the letter u except for a placeholder. It's just weird and almost inappropriate in this settings to use u, so instead I'm using g.
Well, no, I mean like in the way of like having that, like not really clear about like how it's written. It's
We had
just
to
like
pay for it a
that
little bit.
equation into the final one. I don't know if I'm making sense.
I don't think I understand your question. Okay, that seems fair. I wasn't going to do the first one with you, but I will do at least the first one with you. It says, given the following information, find the value of the derivative of f of x at x equal to 3. We are going to take the derivative of every single one of these using a table. There are all sorts of rules all mixed up together. You have to decide what rule to use and use it. So for this first one, I'm looking at f of x equal to g of h of x. Well, I see that h of x is tucked inside of g of x. That means I'm going to have to use what rule to find the derivative? The chain rule. The chain rule says that if I take the derivative of f at 3, I want this to be the derivative of g at h times the derivative of h. So it's the derivative of the outside with the old inside tucked in multiplied by the derivative of the inside. Then we just read our table.
So if we're only finding 3, can I just cross out everything but 3?
No.
Why?
This is a great question. He just asked, if we're only finding x equal to 3, can't I just cross everything else out? It was like that perfect moment, because guess what? What is h of 3?
Negative 8.
Which means I'm finding g prime of what number?
Oh.
8. I needed an additional number in my table. Don't cross it out. That was a great timing for your question. Couldn't have asked for better. Now, h prime of 3 is a value in the table that's negative 5. What is g prime of 8? Pi. So I have pi times negative 5, which means this first one is negative 5 pi. Your job with your team is to answer the other 11 on here. You might use the sum and difference rule. You might use the product rule. You might use the chain rule. You might use the quotient rule. You might use the sum and difference rule.